For those trying to get their head around the tricks a VR headset uses to keep things running silky smooth, it can be a bit of a headache. In today's video, we are going to explain how some of this technology works and use a VR environment itself to help us do so. Time warp. This is the simplest of tricks used to lower the perceived latency of the image being rendered. Nothing to do with frame rate yet. Time warp is the software shifting or warping of the frame being rendered so that when it reaches the screen it is closer to what should be rendered if this process was instant. This happens after the frame has been rendered. Rendering obviously takes far longer than shifting some of the angles by a few degrees. Once this has been warped to account for the movement, it is immediately sent to the headset, so although if you look closely it will look rather distorted, frames flashing past 90 times a second get interpreted by the brain as what it is expecting to see. Asynchronous time warp. This is the same concept as before, but used to reduce the effect of dropped frames. Normally frames which have not been rendered in time are binned by the GPU and it moves on to the next frame. But with asynchronous time warp, if the next frame isn't ready, it uses the previous frame and warps it using the same tracking data as the time warp, but this time to generate a whole new frame, rather than just alter an already existing one. Asynchronous means it alters the previous frame while the next frame is being rendered as a backup, rather than waiting to see if the next frame will be rendered in time. Asynchronous reprojection is Valve's name for the same thing. Both of these mean that FPS of 45 can look like 90 with very little noticeable difference. Asynchronous space warp. I hope you guys are seeing the pattern here. This is the same idea as before, but instead of just tracking rotational data from the headset, it also monitors the objects in frame to try and account for positional headset changes, and again creates a backup frame from the previous frame to lessen the impact of slow frame rendering. This, like asynchronous time warp, is not always enabled, so when a program is dropping frames all over the place for a few seconds, either can be activated and it runs the program at 45 FPS, with asynchronous space warp or time warp filling in the other 50% of the frames. Pretty nifty. This is especially useful for games that have certain areas where the frame rate would otherwise drop too low, but for most, the game is totally playable. What could possibly be next for time warp, I hear you ask? Well, positional time warp, of course. This actively monitors the headset's position in 3D space, rather than just guessing from colors in the frame as with asynchronous space warp. This will only work with programs though that submit their depth data, but with a few updates and the clear benefits, this isn't a problem and offers a greatly increased level of accuracy over asynchronous space warp. Thanks for checking out this episode of Explained in VR, and do remember to subscribe and like the video as that helps us a lot. Also feel free to share this with anyone who you think it would help and embed and use anywhere you want. Just give me some credit if you do so. If you have any other ideas for things you want to be explained in VR, although not just related to VR, then do let me know in the comments below and I'll be sure to read through and do that for the next video. Again, thanks for watching and see you next time.